This conference will now be recorded.
So good morning to everyone. Today we are going to see about the topic of harmonics. So under the harmonics, we are going to discuss about the topic of voltage versus current restoration. So what's in the voltage restoration and current restoration? Harmonics versus transients, and the effect of harmonics in power system line, and what are the common source of harmonics in the power systems. So these are the things we are going to discuss on today. So now we are going to see on the voltage versus current restoration. So harmonics oftenly happened. The harmonic voltages are too great, or harmonic currents are too great, or both due to the harmonic voltages and current. So because of the voltage and current will be disturbed, the waveform has been get disturbed because of that. The harmonics has been introduced in the system. How the harmonics has been introduced in the system? It is due to the non-linear loads which is present in the distribution systems. So due to the nonlinear loads, it will create sources of harmonic current in shunt with injecting harmonic currents into the power system. So due to the nonlinear loads, for example, this is a power system, okay, generating station, so transmission. So now I am going to connect a load here, okay. So this is a load. Particularly if I am going to connect a nonlinear load, so nonlinear load, okay, what will happen means it will inject the harmonics into the supply side of the power generation system. So automatically it will disturb the sinusoidal waveforms. So this is a normal sinusoidal waveform. Harmonics injection automatically and harmonics multiple integer of frequency. So I can say third order harmonics meaning normal fundamental frequency and 50 Hz third order harmonics 50 into 3, it is called as a 150 Hz replica. So automatically waveform it is going to get disturbed because of the harmonics which is present in the system. So harmonics எப்படி வந்து சிஸ்டத்துக்குள்ள introduce ஆகுது அப்படின்னு பார்த்தீங்கன்னா, it is only due to the non-linear load which is connected in the power system line. So non-linear, what will happen if I am going to be connect the non-linear load in the system? Due to the presence of non-linear load, automatically it will inject the harmonic current into the power supply system. Automatically my supply voltage is going to get disturbed. And a pure sinusoidal wave supply பண்ணிட்டு இருந்த சிஸ்டம் என்ன ஆகும்னா, இந்த ஹார்மோனிக்ஸ்னால எனக்கு என்னன்னா வேவ் ஃபார்ம் டிஸ்டோர் ஆகி எனக்கு மல்டிபிள் இன்டீஜர் ஆஃப் ஃப்ரீக்வன்சிஸ் வந்து பார்த்தீங்கன்னா ப்ரெசென்ட் ஆகும். ஆட்டோமேட்டிக்கா என்னோட வேவ் ஃபார்ம் வந்து பார்த்தீங்கன்னா கெட் டிஸ்டோர்ட் ஆகும். So this is just going to be happen due to the harmonics. So now what is the voltage distortion? It is a result of disturbed current passing through the linear series impedance of the power delivery system. So by that your voltage is going to be get distorted. Okay, if my current is get distorted, automatically my voltage also get distorted. Okay, so I am going to be considered a simple system. This is a generating station. It's a pure sinusoidal wave. So this is a transmission line impedance, and next I am going to be connected non-linear load. What is meant by non-linear load? It is a power electronics based converters. Wherever I am using a power electronic based load, that one is said to be called as a non-linear load. And if the harmonic current has passed through the impedance of the system, so my harmonic current passing through the impedance of the system causes a voltage drop for each harmonics. So these result in voltage harmonics appearing in the load bus. இப்போ நான் power electronic components வந்து load endல யூஸ் பண்றேன், இப்போ எனக்கு ஹார்மோனிக் கரண்ட் உள்ள பாஸ் ஆகுது அப்படின்னா ஆட்டோமேட்டிக்கா இங்க எனக்கு வோல்டேஜ் ட்ராப் வந்து பார்த்தீங்கன்னா இம்பெடன்ஸ் லைன்ல இட் இஸ் கோயிங் டு ஹேப்பன். At the same time, the voltage harmonics also it is going to be entering into the particular load. So automatically load on harmonic center load it is going to get disturbed. So and the voltage disturbed voltage it depends on the impedance which is present in the particular transmission line. Okay, how I am going to be control the harmonics in the power system line? So based on the IEEE standard 519.992.1992 recommended the practice and requirement for harmonic control in electric power systems. So based on this particular standard, I need to be maintain the harmonic limits in the power system line. Okay, so this is the thing. So இப்போ எனக்கு ஹார்மோனிக்ஸ் உள்ள இன்ட்ரோடியூஸ் ஆச்சு அப்படின்னா ஆட்டோமேட்டிக்கா எனக்கு என்ன ஆகும்னா என்னோட pure sinusoidal waveform வந்து பார்த்தீங்கன்னா it is going to be disturbed due to the multiple integer of the frequencies present in the system. Okay. So what after that, what will happen? The load has no control over the voltage. The same load in two different locations will result in two different voltage distortion values. So it will affect the end user application. The control system impedance is due to the system impedance, the voltage distortion limit value is going to be changed. So these are the things will be happen if the harmonics is introduced into the particular system. Where the harmonics is applicable means it is applicable whenever you are going to be use of power electronic based components or power electronic based converters. So that kind of load introduce the harmonics into the power system line, either in the supply side or either in the load side. So if the harmonics has introduced into the system, automatically there is no control over the voltage. At the same time, it reflects different voltage values at different location wherever you have load is connected to the power system components, power system line. Okay. So next one is a harmonic versus transients. So what is the difference between the harmonics and what is the difference between the transients? So I need to be categorize the meaning of harmonic. I need to be categorize the meaning of the transients. So the harmonics means it is said to be called as a multiple integer of frequency which is present in the power system. A transience means it is a small disturbance will create a waveform distortion. So there is a small disturbance due to the how the transients occur in the power system. It is due to the oscillatory and impulsive transients. Whenever I'm going to switch over the capacitor switching or lightning strikes in the power system line, it will create this transients for the short period only. But harmonics, it will create a waveform distortion for the long durable period. So with the help of filters only, I can able to remove the harmonics. But transients, it can settle down in the few period of cycle. It can settle down their oscillation values. Okay. So next, the transient disturbance contains high frequency components. They are the natural frequency of the system at the time of switching operation. இப்போ நான் கெப்பாசிட்டர் ஸ்விட்சிங் ஆப்ரேஷன் பண்றேன் அப்படின்னா அந்த இடத்துல வந்து பார்த்தீங்கன்னா டிரான்சியன்ஸ் அக்கர் ஆகும். பட் அந்த டிரான்சியன்ஸ் வந்து பார்த்தீங்கன்னா இட் ரிட்டர்ன் டு த நார்மல் கண்டிஷன் வித்தின் a few period of cycle return it will be returned. But there is a no relationship between the fundamental frequency. So transients எடுத்துட்டோம்னா there is a no direct relation with the frequency value of the system. But harmonics எடுத்துட்டோம்னா it is directly related with the fundamental frequency of the system, because we can say that the fundamental frequency f1 is equal to 50 hertz. Okay, if I am going to be say the third order harmonics f3, third order harmonics, if it is introduced, it is I can say that 3 into f1, that is a 3 into fundamental frequency. So multiple integer of the fundamental frequency. So automatically my frequency value has been replicable to the value of 150 hertz. So normal frequency component is 50 hertz, but the presence of a harmonics, it will shows that the fundamental frequency value is 150 hertz. Automatically your voltage and current is going to get distorted. Okay. So harmonics அப்படிங்கிறது வந்து பார்த்தீங்கன்னா fundamental frequency-யோட relate ஆயிருக்கு. Transients-ங்கிறது வந்து பார்த்தீங்கன்னா it does not going to be related with the fundamental frequency. So how the transients occur? It is due to the switching of the load or switching of the capacitor bank or due to the lightning strike, the transients is introduced into the system. It will disappear in a period of cycle. But harmonics, if the harmonics present in the system, it will disrupt the entire voltage appear in the power system bus. Okay. So waveform distortion. In terms of waveform distortion, the waveform distortion that produces a harmonics is present continually or at least for the several seconds. But transients are usually dissipated within a few cycles of time whenever the transient has appeared in the power system line. Next, the transients are associated with the changes in the system, such as switching of capacitor bank. Harmonics are associated with the continuing operation of the load. ஸோ டிரான்சியன்ட் எப்போ அக்கர் ஆகும் அப்படின்னு பார்த்தீங்கன்னா, நான் கெப்பாசிட்டர் பேங்கை சுவிச் ஓவர் பண்ணும்போது இந்த டிரான்சியன்ஸ் இட்ஸ் கோயிங் டு பி அப்பியர் இன் தட் பர்டிகுலர் லைன். Whenever I am going to use a continuous operation of the non-linear load, will introduce the harmonics in the particular system. Okay, so this is the differences between the transients and harmonics. Okay, so now I'm going to define the power definition for the under non RMS voltage and current. It is termed as S is equal to VRMS into IRMS. So now the VRMS is equal to 1 by square root of V1 and IRMS is equal to 1 by square root of I1. Okay. So now I am going to be express the VRMS and IRMS for the terms for harmonics voltage and the harmonic current. I am expressing this term for the apparent power. Next is the active power. The active power, the average rate of delivering the energy. So now I can write an equation as P stands for the active power is equal to voltage into current divided by 2 into cos theta. It means the power factor. So now automatically V1 I1 cos theta is equal to S cos theta. So this is the equation for the active power. Next, we are going to see on the topic of reactive power. Reactive power is the portion of the apparent power that is out of phase or in quadrature with the active power. So now I can simply term as a definition of Q is equal to S into sine theta 1. So Q is equal to reactive power is equal to apparent power into sine theta. So now the term is expresses V1 I1 divided by 2 sine theta 1 is equal to V1 RMS I1 RMS sine theta 1. So it is in terms of V1. So it is the voltage and current expressed in terms of RMS. So that the equation has been varied. Okay. Now the power factor is defined as the ratio of useful power to the performed real work. That it means the active power to the power supplied by the utility system. So that is an apparent power. So it is a ratio of active power divided by apparent power. So active power is termed as P, apparent power is termed as S. So therefore the power factor is equal to P by S. That is a real power divided by apparent power. Now, due to the harmonics present in the system, what are the effects will happen on the equipments? So the first effects of an harmonics is the insulation stress, thermal stress, load rupture, effect of transformer. So now we can say that if harmonics is continuously present in the system, it causes a stress on the insulation in the particular system and due to the voltage effect. If due to the current restoration value, it will create a thermal stress in the power system line. Due to the abnormal, the harmonic is present in the system will create an abnormal operation. It can cause us a load rupture also. The load will be going to be get damaged, or the load will be going to be getting burst out. Okay. Next, if the harmonics present in the transformer, it will cause us additional heat and it leads to mechanical insulation stress. And because of the mechanical insulation stress, the core vibration is going to happen. If the core vibration is happen, automatically the eddy current loss is also going to be happen. So it is finally leads to the square of the load current into frequency. Automatically, the frequency of the value of the transformer is going to be changed out. So these are the harmonic effects on the equipment. If the harmonics present in the transmission power system line or the component where the system is connected, it will be the voltage distortion causes the insulation stress, the current distortion causes the thermal stress on the system, and abnormal operation causes the load rupture. In the transformer, causes the additional heat. Additional heat leads to the mechanical insulation stress, and mechanical insulation stress causes the core vibration, and core vibration leads to eddy current losses. It finally the resulting change in the square of the load current and the frequency. So because these things will be happen due to the harmonics. So harmonic effects on the power system equipments. So we have going to see the topic in detail aspects. Now we are going to discuss on that what are the equipments will be affected due to the harmonics. So first equipment is the motor. So if the harmonics has been introduced in the motor, automatically what will happen? It will result to increased losses. The harmonic voltages produces a magnetic field rotating at a speed corresponding to harmonic frequency. So these effects will create a heating in the motor. Mechanical vibration and noises will be created in the motor. The torque will be pulsating. The efficiency of the motor is going to be reduces, and the insulation experience the voltage stress. So if the voltage stress is very much more, the insulation is going to break it. So this is the first equipment. Next equipment is a circuit breaker. If the harmonics has been introduced in the circuit breaker, what will happen? The coil will be blow out. It does not operate properly in the presence of harmonic current. Yeah, harmonic current, if I'm saying that the normal current is different from the harmonic current. Harmonic current has been present in the system. It is the current which is present more than the nominal current. So it will cause us the coil to blow out. So automatically what will happen? It is a failure to interrupt currents. So automatically the circuit breaker is going to get failed. It will cause us an interrupt in the unwanted interrupt in the power system lines. So this is the presence of harmonics in the circuit breaker. So wherever the harmonics has been introduced in the system, the equipment wherever it is connected in the power system line is going to be affected with the help of it is due to the harmonics. Harmonics and வந்து லைன்ல பிரசன்ட் ஆச்சு அப்படின்னா அதுல கனெக்ட் பண்ணிக்கூடிய எக்யூப்மெண்ட் ஒவ்வொன்றா வந்து பார்த்தீங்கன்னா டேமேஜ் ஆகும். So now we are seeing the equipment, detailed equipment, what are the effects of harmonics and what is the result of the particular effects of harmonics present in the system. Okay. So next one is a electromechanical induction disk relays. So it is a type of the protection and switchgear relays. So what will happen if the harmonics has been introduced in the induction disk relays? It will alter the time delay characteristics of the relay. Automatically, if the time delay characteristics has been changed, automatically it does not respond to the fault occur in the system. Automatically, the fault current will transfer to the corresponding load. Automatically, the load will get ruptured. Okay, so due to the harmonics, it will alter the time delay characteristics. So it causes an incorrect tripping of the relays. Or எப்போ உனக்கு கரெக்டாக ட்ரிப் ஆகணுமோ அந்த டைம்ல ட்ரிப் ஆகாம ஃபால்ட் கரண்ட் உள்ள என்ட்ரு ஆனதுக்கு அப்புறம் ட்ரிப் ஆகிறதுக்கும் வந்து பார்த்தீங்கன்னா there is a possibility it is due to the harmonics. Next one is a watt hour meter. It is an energy meter reading. So harmonics generates additional torque on the induction disk, which causes an improper operation. So it leads to what is the result of the particular effect? It leads to incorrect readings. So automatically your power meter is not recorded the correct reading what's supply we have been observed. Next one is the electronic and computer controlled equipment. So what will happen in the electronic and computer controlled equipment? The effects of harmonics leads to electronic controls are independent of zero crossing or on voltage control. So what will happen? If the effects is perhaps automatically the results the more operation of the control and protection equipments and the equipment is going to get failed. Okay, if the harmonics has been introduced in the electronics and computer control equipment, automatically it leads to more operation of the control and protection equipments, and the equipment is going to get failure. So these are the things. So this is the thing will be happening with the help of harmonics. So next capacitor, the equipment category is a capacitor. So effects of harmonics in the system, the capacitor impedance decreases with the frequency. The supply system inductance resonate with the capacitor. So it means that it will create the resonance automatically. We can know that resonance means XL is equal to XC. So if the capacitor value decreases with the frequency, automatically the value is not equal to XL to XL equal to XC. So the resonance condition perhaps automatically it will create a harmonics has been introduced in the particular system. It causes large current and the voltages enter into the power system line. So this topic we have seen on the yesterday classes. Okay. So next what will happen if the harmonic current present in the capacitor will break down the dielectric strength of the material. So this is a in between the two plates there is a dielectric strength is there. So the dielectric property will be damaged due to the harmonic currents. So what will happen? It results capacitor will be heated, short circuits will be happen, the fuse will be failed, or capacitor may be exploded due to the harmonic currents present in the system. If the harmonic current passing to the, for example, this is a capacitor, if the harmonic current passing continuously to the system, what will happen means the capacitor will be heated, short circuit of two plates, fuses will be blown out where the capacitor has been connected. Next, sometimes the capacitor is going to be get exploded. So these are the things that is due to the effects of harmonics in the capacitor. So next, the harmonic effects on the power system transformer. So what will happen? It will lead to high losses. So it results in transformer core get heated, reduce the lifespan of the devices. Copper and iron loss will be increases. The insulation stress is increases, and noise will be created in the particular transformer. So these are the effects of power system equipments. So now we have seen on the equipments of motor. If the harmonic current on the motor la pochu appadina, these are the results. Motor heating, mechanical vibration, noises, pulsating torque, reduced efficiency, voltage stress on the insulation. If the harmonic current enter into the circuit breaker, it will cause us to interrupt the fail to interrupt the current. That is a short circuit current in the power system line. So next, electromechanical disk la vandu harmonic current induce aachu appadina, it may causes a time delay characteristic, alter the time delay characteristics. It will result in incorrect tripping of the relays. Watt hour meter la, if the harmonics enter presence of harmonics in the watt hour meter, it causes a additional torque on the induction disk for additional torque on the induction disk, which causes an improper operation. It leads to incorrect reading of the machine. Next, if the harmonics enter into the electronic and computer controlled equipment, it will lead to mal operation of control and protection equipments. The equipment, sometimes the equipment is going to get failed. Next, the harmonic effects on the capacitors. If the harmonics present the capacitor, it leads to heating of the capacitor, short circuit, fuse failures, and the capacitor may be exploded at a high level. Next one is a transformer. So if the losses effects is a high losses, and results on the results of the harmonics leads to heating of the core in transformer. Lifespan of the device is going to be reduces. Automatically, it will increase the copper and iron losses, and the stress perhaps on the insulation of the transformer winding. So it leads to insulation failure also, and it creates the noises also. Sometimes the transformer also going to be get failed to operate. So these are the harmonic effects on the power system equipments. So next one is a common source of harmonics. So what are the common source of the harmonics? Harmonics generate ஆகிறதுக்கு காமனா என்னென்ன சோர்ஸ்ல இருந்து ஹார்மோனிக்ஸ் வந்து ஜென்ரேட் ஆகுது. ஸோ இதை வந்து பார்த்தீங்கன்னா நம்ம வந்து லோட்ஸை வந்து பார்த்தீங்கன்னா லோட்ல தான் வந்து பார்த்தீங்கன்னா ஹார்மோனிக்ஸ் வந்து ஜென்ரேட் ஆகும், சிஸ்டத்துக்கு என்டர் ஆகும். ஸோ அது என்னென்ன டைப் ஆஃப் லோடு வந்து அப்படிங்கிறது ஃபர்ஸ்ட் நம்ம கேட்டகரைஸ் பண்ணணும். ஸோ ஃபர்ஸ்ட் லோடு வந்து பார்த்தீங்கன்னா ஐ கேன் சே தட் இஸ் இண்டஸ்ட்ரியல் லோடு. Next one வந்து பார்த்தீங்கன்னா commercial load. Next one is a residential load. So the total loads is going to be classified into residential, commercial, and industrial. So by that I am going to be classify the source of harmonics. So from the industrial loads அப்படிங்கிறது வந்து பார்த்தீங்கன்னா what are the industrial loads? I can say that 3-phase power converters, variable speed drives, PWM adjustable speed drives, welding machine, large UPS system, lightning system, that is a discharge lamps, and electric furnace. So these are categorized as the industrial loads. It will introduce the harmonics in the power system line. It will create the problem of overheating of the supply transformer, tripping of overcurrent protection devices, and overheating and fuse blowing of power factor correction capacitors. So these are the common problems that will be happen due to the industrial loads. Okay, once again I am saying that this is the first industrial load. The industrial load is going to be categorized as 3-phase power converter, variable speed drives, adjustable speed drives, welding machine, large UPS systems, and discharge lamps, and electric furnace. So because of the sources, the harmonics will be created in the system. So it will result in what are the types of problem? Overheating of the supply transformers, the tripping of the protection devices, and due to the overheating, the fuse may be blown out, and also the power factor correction capacitor also sometimes it is going to be blown out. So it is only due to the industrial loads. Next source, it is categorized as a commercial loads. So what are the commercial loads? The power supplies, SMBS, switched mode power supply, switching regulators, Adjustable speed drives in HVAC system, high voltage AC systems, computers, electronic office equipments, lighting like fluorescent lamps. These are categorized as a commercial. கமர்ஷியல்னா ஒரு இடம் வாடகைக்கு எடுத்துக்கிறோம். வாடகைக்கு எடுத்தா அங்க வந்து பாத்தீங்கன்னா ஃப்ரிட்ஜ், ரெஃப்ரிஜிரேட்டர், ஆட்டோமேட்டிக்லி ஏசி, லேம்ப்ஸ், லைட்னிங் பர்பஸ்லாம் யூஸ் பண்றோம் பாத்தீங்களா, லிஃப்ட் போடுற இது எல்லாமே வந்து பாத்தீங்கன்னா இட் இஸ் வந்து கிளாசிஃபைட் as a commercial loads. So commercial loadsங்கிறது வந்து பாத்தீங்கன்னா these are the commercial loads. So these, because of this load, the harmonics has been introduced in the particular system. What will happen? It is causes again overheating of the supply transformer. Whenever the harmonics is going to be introduced into the system, it causes the transformer to overheat. Automatically, the insulation of the transformer is going to be break down due to the overheating. Because the overheating will cause the insulation stress on the insulation. So automatically the insulation will be get failure. At the same time, the overheating of the neutral conductor causes the conductor to be broken out. Automatically, supply will be interrupted. So these are the things will be happen due to the commercial loads. So next one is the residential load. So the residential load means we can use a personal computers, lighting, and electronic gadgets, what we are using in the homes. These are categorized as a residential load. So because of this particular residential load, the harmonics has introduced in the system. Wherever you are using these kind of loads, automatically the harmonics is present in the negligible amount. But all the devices manufactured according to the IEEE standard of 519992 with a negligible amount of harmonics. I can't able to eliminate a whole harmonics in the system. I can able to maintain the harmonics level in the according to the IEEE standard. So all equipment has the harmonics, but it must lies with the IEEE standard. Okay. So it will create, what will happen? It will create high density of the electronic loads, causes overheating of the utility transformer. Where the your EB is connected to the transformer going to be causes overheating. So these are the things will be happen. Okay. So this is the sources of harmonics, common source of harmonics. Common sources will be classified as industrial loads, commercial loads, and residential loads. Due to these, the all problem will cause is overheating of the transformer. If the harmonics present in the system, automatically it will affect the transformer lifespan. So due to the overheating, it will create the stress on the insulation level. So after withstand capability, the insulation is going to be get breakdown. Automatically, the transform function is going to be getting interrupted. The supply also going to be getting interrupted. So this is going to be happen in the short period of the harmonics introduced in the system. So far what we have been seeing. So we have seen the differences between the voltage versus current distortion. So voltage versus current distortion, and what is mean by harmonics, and what is the difference between the harmonics and the transients, and the effects of harmonics on the particular devices like motors, circuit breakers, transformers, induction disc relays, watt meters. So these are the things we have been seen on the effects of harmonics on the power system equipments and the common source of the harmonics. So what are the common sources? How the harmonics has been created? What is its source? It is a source. It is classified into three category of load. One is the industrial, residential, and the commercial load. Okay. So by that we have going to categorize the sources of harmonics. Thank you. So just I am giving a brief introduction about the harmonics and the difference between the harmonics and transients, and normal effects of harmonics present in the system. So these are this video is content is related to the just given introduction about the harmonics and effects of harmonics in the power system equipments. Thank you.